In example one, we want to show function transformations. So first thing is we want to differentiate inside and outside. So the outside I've highlighted in green, which is our y transformations, and the inside I've highlighted in red, which is our x transformations. And y's happen the right way around, the x's happen exact opposite. So I'm going to start with our y transformations because they're easy. So our change in y is basically going to be times by -2. So our change in y is going to be our new y is going to be all our old y's multiplied by -2. So it's going to be a vertical flip and a vertical expansion. So I'm going to take all those y coordinates and multiply them by -2. So I get 0, -2. 2 times -2 is -4. And 3 times -2 is -6. So those represent all my y transformations. With the x transformations though, it's easiest done if we rearrange this into its factored form. And to do that, what I want to do is I'm going to take our notation and I'm going to take all that expression and I'm going to expand it out and then I'm going to put it into factored form. So I'm going to end up with 3 over 2x minus 3 and then plus 1. I'm going to combine those terms. So 3 over 2x minus 3 plus 1 is -2. And now I'm going to put it into factored form. So 3 over 2x. And when I factor this out, I'm going to end up with dividing by 3 over 2 or multiplying by 2 over 3. And I'm going to end up as 4 over 3. Okay, so when I describe this transformation, this is going to be, and I'm going to rewrite this, it's going to be equivalent to -2 square root, and then we can write that expression in factored form on the inside. And this is, in the factored form, we're always going to be expressing this as a compression expansion first, and then shift last. Okay, so we're going to, in this case, compress by 1.5, or multiply that by, compress by 2/3, and then shift 4/3 to the right. Okay, so, and if I'm going to describe my transformation, I'm going to do it here. My change in x is going to be first, it's going to be horizontal compression by 2/3. It's going to then be a horizontal shift to the right 4/3. Okay, and so if I were to show my calculations, my new x is going to be times by 2/3 and then plus 4/3. Okay, so times by 2/3 plus 4/3 is going to give me plus 4 over 3. Times by 2/3 plus 4/3 is going to give me 6 over 3, which is 2. Times by 4, 2/3 plus 4/3 is going to give me 8 over 3. Okay, 9 times 2/3 plus 4/3 is going to give me 18 over 3. So these then represent my new coordinates. When I plug them in, it's going to be 4/3, 0, 2, -2, 8/3, which is about 2 and a bit, and -4, so maybe something around there. Okay, 18 over 3 is going to be same as 6. I should really rewrite that as 6. That's going to be equal to 6. Oops. So 6 over, 6 down. Okay, so there's my coordinate there. And so it's going to be, the graph is upside down. It's going to be stretched, flipped and expanded by 2, and then it's going to be compressed and shifted over 4/3 to the right. Now, we could also do this so that's using factored form. That's going to be the easiest. The other way we could do this is we can use an undoing method, an undoing strategy. So we can take our notation. It's going to look like this. It's going to be 3x minus 6 over 2 plus 1. And then we can just undo this expression and solve for the other x. Solve for the embedded x. So I end up with 3x minus 6 over 2 is equal to x minus 1 times both sides by 2. I'm going to add 4 to both sides. And then I'm going to divide both sides by 3. So I end up with my 2/3 plus 4 over 3. And that's essentially what I did. So you can see that what I did using the factored form, I got this result. And then using the undoing strategy, I'm going to get the exact same transformation. My change in x is going to be, this is what I'm going to end up doing. I'm going to do this times by 2/3 and then plus 4 over 3 to get the changes in the x values.